Hey guys, welcome back to COSC 2325. In this video, we're going to look at the flags that are affected by arithmetic. So the arithmetic logic unit has a number of status flags that reflect the outcome of arithmetic and bitwise operations based on the contents of the destination operand. Remember the destination, like if you have move, MOV, and you have move, let's see here. So if we have move, and then we have a register here called AL, and we want to move a 5 to AL. The destination is AL. So depending, and move does not affect flags, but when we talk about the operands, depending on what operand we have here, and what happens, what the contents of this operand is, that's what flags are going to get set with add, subtract, negate, and some of these different mnemonics that we're going to be using. So the essential flags are these 4 flags, and these are the ones that we're going to be really looking at first, really closely. And you need to make sure that you at home are using Visual Studio like I am, writing these programs and looking at the flags. Otherwise, you're not going to be able to learn this. You're going to be required to know this for your exams and your quizzes and for coding. So you'll need to be able to look at code and see what flags get set depending on the code. So we're going to look at the 0 flag, which is set when the destination, so when something in either a register or a variable is equal to 0. A sign flag is set when the destination is negative, so either the register or the variable has a negative value in it. The carry flag is only set when unsigned value is out of range. Remember, when you define something, for example, as a byte, just BYTE, you've now defined a memory location that is unsigned because you did not put the S in front of it for signed. So if that byte that you define, that memory location, let's say it's called var1, is out of range, and a byte range is from, when it's unsigned, is from 0 to 255. So if it's a negative number, or if it's something 256, 257 above, then this carry flag is going to get set. If it's a signed memory location, so if it's a signed value and it's out of range, then the over flag gets set. So let's say that you've defined S byte, var1 is S byte. Now it's signed. Now the only range that it could have is between negative 127 and positive 127. Important, the move instruction never affects the flags, and we'll look at that as we're coding. Let's see here. Okay. So the first flag is the carry flag. And in Visual Studio, we're going to see that there's going to be a CY that shows us that flag. It's going to be called CY in Visual Studio. So the carry flag is set when the result of an operation generates an unsigned value that is out of range. So here's an example. And I actually have this already typed up. And what I want you to do at home is, pause the video, type this program in because you're only going to learn it if you type it in and you do this. If you just watch me, it's like trying to learn the piano. You can't learn the piano by watching somebody play it. You actually have to try it yourself. So let me get this out of the way here. So what I've done is I've added this code right here. You don't need to add this right now. This, I'm not going to use it right now. These variables. You just have to add these 3 lines, and you don't have to add the comment. So the first thing that we're doing here is we're moving 0 to EAX register. So we're just clearing out the register so that we see all zeros and we don't see garbage in the register, because then we're only going to use the lower half of the 16 bits of the AX register. And we're going to put the number FF hexadecimal. And FF hexadecimal is a -1. Then we're going to, so we're moving a -1 into AL, FF. Then we're going to add 1. So that's going to make it a 0. So the AL register will have a 0. And we're going to see that the carry flag is going to be set to 1 at this point. Okay, so let's take a look at this running. So I'm gonna put a break right here in this move. Actually, let's put the break here. It's giving me an error. It's saying, oh, it doesn't like my comment here. Let me see what I did. I was messing with it earlier. So there we go. So I have a comment. I commented all this out so that the only thing that runs is this right here. All right. So right now, EAX has all this junk. This line right here is going to make this 0. So I'm going to step over. So EAX gets all changed to 0. Then I'm going to move FF into AL. There's FF right there. Remember that it's only using the, so EAX is 32 bits. I'm sorry, yeah, 32-bit register. And then half of that is 16. So that would be the AX register. And the AL is just 8 bits or 2 bytes. So this right here is 2 bytes. Remember when we say a 32-bit register, and I just want to make sure you understand. So 32 bits and more 8 bits is 1 byte. So you have, I keep saying, yeah, so 32, if you have 32, it would be 8 plus 8 is 16. You have 4 bytes. So, let's see here. So now that we have FF, now we're going to add 1. So we're going to step over. Notice that my move statements, these are my flags here. Oh, by the way, to get the flags, when you're here looking at the registers, you right click on this area and you click and you check flags. So there my flags go away. I right click and I show my flags. Okay. So now I'm going to step over this one. And I've stepped over add 1 to AL. So when we add 1 to AL, the register gets a 0, and my carry flag is set to 1. And I'm not looking at this flag right now. I'm just going to look at the carry flag, which just gets set to 1. So remember, this says that the carry flag is set when the result of an operation generates an unsigned value that is out of range. It's either too big or too small for the destination operand. So if we look at this example, we move 0 into AL, and then we add 1 to 0. I'm sorry, we subtract 1 from 0, we get FF, which is the same thing that we just did, except FF will be negative. So we're actually going to see another flag getting set. I'm going to go ahead and stop this. And I'm going to put the comment here. So again, so the carry flag gets a 1. And then now I'm going to move 0 into AL. And I'm going to subtract 1 from 0. So when 1 is subtracted from 0, we see that carry flag stays a 1. PL is a sign flag. This is the one where now it's negative. We set it to negative, so my AL is negative, so it sets the flag to 1. And then the 0 flag gets set because I don't have that here. Meaning 0. So 0, it's not that it got set. It was set earlier when it was set to 1. When it sets to 0, it means that it's not, that it's cleared. So we've cleared this flag, the 0 flag. It was set earlier. We've made the sign flag a 1 and the carry flag stayed a 1. So let's go back to here. So now we look at the overflow flag. So the overflow flag is set when the signed result of an operation is invalid or out of range. So this is a signed result of an operation is invalid or out of range. In this one, the carry is set when the result of an operation generates an unsigned value that is out of range. So it can be too big or too small for the destination operand. So in this example, we have 127 that's put into 1 byte. Remember that the range of a byte is going to be positive 100, negative 127 to positive 127. So here we're adding 1 to 127, which means that it's going to overflow. The max integer is 127. In this example is exactly like this one, except this is done in hexadecimal. So this is 7F is 127 hexadecimal. So when we add 1, then we get overflow, it's kept at 1, and our register holds 80 hexadecimal. Let's see if I have this one here. I do have it in here, so let's take a look at that. So let's start here. Anytime you edit your program while it's in debug, it's going to give you that error. That's why I give you that error. I have to stop it first. Okay, so at this point, also, if you see this, go down here to these tabs and just go back to your registers tab. This is my watch tab to watch my variables later when I deal with these variables. I'm not dealing with them right now. Okay, so we're gonna move 127 into AL. So AL right now has FF in it from here, from this instruction. I'm gonna go forward one, and now it has 127, which we know it's 7F. We just talked about that in the PowerPoint. So 7F is 127. And then when we add 1, it's going to overflow. So look at these flags right here. So the overflow flag, overflow flag is this one right here, and it gets set to 1. Now these are zeros. This means that these are cleared. 0 means that they cleared the flags. This means that they set the flag. So this one was set to 1. So it means no carry, and we're not dealing with this flag right now. Okay, so we're going to stop and take a look at another example. You can try this one also. It's going to be the same thing. It's just we're using the hexadecimal number. Okay, so in this example, we're using an instruction that is called NEG, or negating a number. The processor is going to implement negating. So negating, if the number is positive, it'll make it negative. If it's negative, it makes it positive. So what negate does is it takes the number that you have. So for example, if you have the number 10, it says, what is 10 taken from 0? So 10, so 0 minus 10 is negative 10. That's how it gives you that negative number. So if this operand here, it's a variable that has a 10, it tries to say 10 minus 0, which gives you a negative 10. I mean 0 minus 10, which gives you a negative 10. So let me write that because that may not make any sense. So let's say that my operand is a variable. And my variable is, choose the wrong thing. So I'm not super great at writing with. Okay. I want to spotlight. I want to do yeah. Okay, I can't write with it. I don't know what I did wrong, but so what I want to do is if this is bar 1 here, and bar 1 has a 10, a positive 10, they'll just try to do 0 minus 10, and that's how it gets a negative number. So any non-zero operand causes the carry flag to be set. Any non-zero operand is going to cause the carry flag to be set. So a 1, a 2, a 3 will cause it to be set. And then the carry flag is set when an unsigned value is out of range, and the over flag is set when a signed value is out of range. So earlier we had a non-zero operand that caused our carry flag to get set, and it was this one right here. So if the operand, and we're talking about this operand right here. So for example, if we have negate, val b is the operand that they're referring to. Sorry about that. So we're looking at that operand. So negate only has one operand. If it's in any non-zero operand, will cause the carry flag to be set. And the reason is that if this is a zero right here, 0 minus 0 is just 0. So it's not going to cause it to negate the number. It's not going to cause it to have a negative value. Remember, if it's a negative number, it will set it to positive. If it's a positive number, negate will make it negative. If it's positive, we'll make it negative. So let's look at this. I made something kind of like this, not exactly, but in this example, I broke it down a little bit more so that we could see how this works. So this example is actually this example here earlier. So let's start here with the negate. I'm looking and see what that does. So byte var is not a signed byte, it's just an unsigned byte, and it contains the number 1. So this contains the number 1. So when I do negate 1, I'm doing 0 minus 1, and so byte var is going to be set to will equal negative 1. So because byte var equals to negative 1, because this is unsigned, my carry flag will be set to 1 because now I'm going under 0. And remember that the range of an unsigned byte is 0 to 127. So my carry will be set to 1. And my overflow is going to be set to 0. Byte 2 var is signed, and it contains a negative 128. This is the range of a signed byte. It can be between negative 127 and positive 127. So so this right here, when I make it positive, there'll be 128, which will be an overflow and the carry, my carry flag set. And then var 3 has 0 in it. It's unsigned. So carry will be 0 and overflow will be 0. So remember that carry, once again, carry and overflow, they're kind of confusing. Carry, There we go. The carry flag is set when the result of an operation generates an unsigned value that is out of range. If it's out of range and it's unsigned value, so it's unsigned byte, then our carry flag is going to get set. Overflow is set when the signed result of an operation is invalid or out of range. So we're going to run this again. I'm going to take a observe. Oh, put my comment here. I'm going to comment out this whole block right here. I don't want it to run. All right, so remember byte var is unsigned. So let's see what was in it. I forgot already. It had, okay, it had 1 in it. So number 1. And the range of a byte can be unsigned, can be between 0 and 255. We're going to negate it, so it becomes a -1. Because it's -1, it's no longer between 0 and 255. So my carry flag has to be set. It's not overflowing, but it is a negative number, so it's signed. So my PO flag is 1. And it was probably set from 1 from before, but it's just going to stay set to 1. Okay, so now I'm going to step over. So var2 is a signed byte, and it contains 128. So it is signed, and we negate it, so we made it to byte var positive 128. Well, positive 128 is out of the range also. Therefore, we're going to carry. So carry equals 1. It's overflowing because it's more than 127. So overflow equals 1. So byte var overflow and carry get set. And that's it. Let's take a look at this next one. Oh. So anytime I type something, it just doesn't like it. So I'm going to just rerun it. I'm going to stop, rerun it. So I'm going to get my registers and flags. Step over, step over. Okay, we were at the last one. Byte var 3 contains, it's a signed, unsigned byte, and it contains a 0. Unsigned, and it contains a 0. So 0 minus 0 is just 0. It doesn't do anything. So my carry flag doesn't get set. My overflow flag does not get set. But let's see if our 0 flag gets set. So step over. So there's 0. So the 0 flag actually gets set. Now I know we haven't talked about the 0 flag, but it does get set. Okay. So 0 flag is really easy. It's set when the result of an operation produces 0 in the destination operand. Not a big deal. So right here, we're moving 1 to CX. We subtract 1 from CX. Since we subtracted 1 from 1, we got 0. So the 0 flag got set to 1. It's in here, but with hexadecimal number. So this operation increases AX to 1, to 0, I'm sorry, AX to 0. This increases it to 0. So our 0 flag gets set to 1, and then here AX gets incremented again, so the 0 flag gets cleared. So flag is set when it equals 1, it's clear when it's equals 0. So here we clear it because it's AX is 2. Here we set it because AX is, sorry. Here, AX is 0, so it is set, the 0 flag is set here. AX is 1, so the 0 flag is cleared for the 0. By the way, ZR is what you see in here in Visual Studio. The letters, the acronym that they use for 0 flag. The sign flag is set when the destination operand is negative. The flag is clear when the destination is positive. So if we move 0 into CX and we subtract 1 from 0, then the sign flag is set. If we add 2, then the sign flag is cleared. And this here should just say 1. So in both instances, the carry flag gets set to a 1. So type this in and try it out. And then here at the bottom, it's showing you how that works. So the sign flag is a copy of the destination's highest bit. Remember, this is the highest bit right here. So 1 on the highest bit means that it's a signed number, and 0 means that it's positive. This means negative, this means positive. All CPU instructions operate exactly the same on signed and unsigned integers. The CPU cannot distinguish between signed and unsigned integers. So the CPU doesn't know what is signed and unsigned. You, the programmer, are solely responsible for using the correct data type with each instruction. So when you use the data type signed, then you can take negative or positive numbers. But if you use the unsigned data type, like byte and word, then you can only take positive numbers. So if you ever think that you might get a negative number in your arithmetic, or if you think the user's gonna give you a negative number, then use assigned data type, like sign byte. So the next thing that you're going to try to do is I want you to look at the left-hand side. Don't look at the right-hand side. And for each of the following marked entries, for each one of these that doesn't have a move, so everything that has an add or a subtract, you're going to show the value of the destination operand. So you're going to say, what does AX contain? What does AL contain? BH. And tell us if the sign, 0, and carry flags are going to be set to 0 or 1. And remember, these names are the names, like SF is the name 0 flag, sign flag, but in in Visual Studio, it's going to be PL. And the 0 flag is going to be zero flag is ZR. the carry flag is ZY. So looking over here, check your work after you're done. But first, for example, I'll do this one. If I move FF to AX, then, and I add 1 to FF, then AX is going to contain 100. And so that means that my sign flag is 0. It's not set. It's cleared. My 0 flag is cleared. And my carry flag is 0. So it doesn't affect any of, it doesn't turn on any other flags. If I subtract 1, it goes back to AF, FF. And so everything stays 0. So see if you can do the rest without looking on the right here, and you can check your work using the compiler also. On the next slide, just a rule of thumb. When adding 2 integers, remember that the overflow flag is only set when 2 positive operands are added and their sum is negative. So when you have 2 positive operands, they're added and their sum is negative. That's when the overflow flag is going to be set. Or 2 negative operands are added and their sum is positive. So here's some overflow examples. Here overflow, which is OV, will be set to 1, and here will be cleared. So we're adding 80 plus 92. I'm sorry, we're moving 80 to AL, and then adding 80 to 92 in hexadecimal. And so if you remember, when we're adding 80 plus 92 in hexadecimal, let me see if I can get the. It's right, I don't know. Oh, here we go. Annotate. You guys probably at home are going, at the bottom, click the bottom. Okay, so I'm gonna click on annotate, and then I'm with my color. So if I'm adding 80 plus 92, so we have 0 plus 2 is 2. 9 plus 8 is 17. So that means that I take 17, I subtract 16, and I have 1 left over, and I carry 1. So my hex number comes out to 112. Now, the problem here is that AL is only 8 bits, and 112 will not fit, 112 hexadecimal will not fit into 8 bits. What will happen is you're only going to see the 1 and the 2. You won't see this 1 right here. This is too small. So overflow is going to get set here, We have -2 that gets moved to AL. Then we add, so we have 127 minus 2, which gives us 125. The 125 is in the range. So 125 is like -120. 125 is big enough to fit into AL as a decimal number. So this is a decimal, this is hex. There's a little bit of a difference here. So the overflow will not get set. And then remember that if we want to show what 112 is in decimal, you're going to take this 16. I can magnitude again. So this would be 16 to the power of 0, which will be 1 times 2. So 1 times 2 is 2. This is 16 squared times 1. So 16 times 16 to my calculator. I'm sorry, this is 16 to the power of 1. So that's just 16. We're adding these together, these numbers. This is 16 squared. 16 squared is 416 times 1 is 416. And then when you add all these numbers up, these numbers, when added all up, are going to be bigger than what a byte can hold. So 1 byte can hold from 0 to 255, and it's going to be this big number here. So our overflow flag gets set. Okay, let's clear this. Our pointer. So for these, what I want you to do is pause it and just figure out what will be the values of the given flags after each operation. Try not to look over here on the right, and it's fine if you do, not a big deal. So do each one of these and figure out why is it overflowing. If it is, so this is OV overflow. This is our carry flag, which will be CY. And then in the next video, we're going to look at the data related operators and directives, indirect addressing, and jump and loop instructions. Okay, so play around with those flags. Make sure that you're using Visual Studio to do this. Otherwise, you're not going to get anything out of it. Okay. All right. Good luck with the flags, and I'll see you in the next video. Thank you.